Hello, class. Morning. Okay. All right. Welcome to Noel. Do you have two account here? I see there are two of you. How many accounts? There are so many. Four. How many accounts do you have now? You have one, two. There are two of you here. I think I'm gonna remove one. Yeah.
Oh, use one to listen and use one to talk.
I like to see only one of you using one account. Please don't put an extra account, yeah, because I getting confused with so many. Yeah, by using two device. Just use one, yeah. Just use one. Is there a problem with your device?
Uh, my PC, there's no mic.
Oh, okay. Never mind. All right. Anyway, okay. So first thing we like to introduce ourselves. Maybe after this, let me just introduce the course first. Yeah. First time. Let me just do that. This course is going to be recorded. We will be recording this. Okay. Everybody ready?
Yeah.
So I'll turn off my video for a while, cam. Yeah, because I need to change a little bit of things. Yeah, like it doesn't really. Yeah, there you go. Much better. Okay, so we're gonna do recording on this one. Okay, start. Okay, once again, good morning and welcome to data structure BSCS 2063. First thing I am going to show you introduction, a brief introduction about the whole course for data structure. Yeah. Okay. So let me just do presenting of my tab first. First thing. You tell me if you can see this. If you cannot see, then as well you tell me. Yeah. You are. It is okay to actually use a voice to speak. Yeah.
Uh,
Maybe
can
along the way I will have to, you know, turn off my mic as well. Not mic, my video because of the lag in connection sometime. Okay, can you see this?
yeah.
Class, can you see this?
Can
Can everyone see this?
Yes.
Kelvin and Noel, can you see my screen?
uh can
I cannot hear you, Noel.
hello
You're talking, but I
testing.
cannot hear you. Something wrong with your mic? You're
No, we can.
using. Hello, can you hear me? I cannot
Oh,
hear you.
oh, we
Uh,
can. We can hear you.
Okay, can you type first, please? I think can hear. Okay. How come I cannot hear you? Something wrong with your machine or something wrong with my machine. I cannot hear you. No, I cannot hear you. Okay, wait. Can you turn on your mic again, please? You
Oh,
can hear him.
uh, testing.
Okay, wait. Let me see. Yeah. Um, but you can hear me, right?
Yeah.
This is really weird. Okay, like this. Can you do me a favor? Can you look out for a second, and then you come back in.
Okay.
Okay. So I
Hello?
Testing.
Okay. So now can you say something?
Testing. Testing. Testing.
Cannot hear still. Never mind. Okay, never mind. Let me just sort this out. Yeah, there's something wrong with this. I cannot hear you. Is chat video really weird, right? Okay, but never mind. You can hear me clear? As long as you can hear me, it's fine. You can hear me? You can just type yes. Type. You can hear me, right? Yes, can you hear me? Elvin? No? I cannot hear still. Never mind. Okay, you whenever you want to say, you can just type in the box, yeah, in this chat box, because I cannot hear you. Something wrong with my system, I think. I don't know. But anyway, okay, let's proceed. Let's proceed with this presentation first. This is our course BACS 2063, data structures and algorithm. I will be your instructor for this course, and then my name is Miss Paula. This is my email. If you can see, it's p3950 at tarc.edu.my. Okay, my contact number. Okay, you need to take this because we are going to communicate via WhatsApp group, so that it's easier to communicate and then to relate, transfer information if need be. Okay, so please take my number, and then I think maybe one of you can help me create the group, and be sure to make everyone admin, yeah, so everybody can manipulate or do something which is equivalent to an admin inside the group. Okay, so okay, so let me see that you already sent message, yeah. Okay, we create that in a second, yeah. No, create that group later on, but first let me just present, because we have a whole bunch of information needs to be relayed to you guys. Okay, so all right, let me just proceed. Okay, wait, this is this. Okay, this is our class information. Our class schedule is every Tuesday, like today, and then our lecture will start exactly 9 a.m. to 11 a.m. Approximately, not approximately, it's 2 hours. So if it is in face-to-face class, which is going to start in February, if I'm not mistaken, it's 14 February. Yeah, so that onwards is going to be a face-to-face class. So we are going to meet in B104. And then there'll be another class which is on practical classes. So we will have that today as well, 2 p.m. to 4 p.m. So for face to face, we'll have that at B010. Okay, that's a lab. I believe that's a lab, right? Okay, so done with that. A little bit of important information that you need to know. So all students need to download all class materials, which are basically posted at the Google class. Okay, so I believe you have downloaded some of the notes which I posted. It is a whole bunch of notes for you the whole semester. You can actually go through the materials before attending the classes. Sorry. So an occasion where there are no notes present in space Google Classroom, I will. This is referring to the practical or something like that. So I will give you and share with you during the session. Okay. So next one is student needs to check in your attendance in the TARC app. Yeah, I think you are well aware of this. So but this one is going to only be implemented during the FTF class. So for now, if you have attended this class, okay, so I will mark your attendance manually. Okay, so this is very important if you say, for example, during face-to-face class. Okay, if you are unable to, if you forgot, for example, to actually check in for your attendance, this is going to be recorded as absent, and this is a very not a pleasant thing as a student, because that is going to affect everything else along the way. For example, attendance, allowance for exams and all that. Okay, next one. So your coursework, this is what I got from the current information. Yeah, your coursework is actually apply. Okay, this is course learning outcome for this course. There are various course learning outcomes, 1, 2, and 3, CLO. Yeah. So you, by the end of the course, okay, or the exam or coursework, you're supposed to be able to apply various data structures and algorithms to solve programming problems. Number two is to produce a software program using appropriate data structures and algorithm. Next one is to explain implementation appropriateness of data structures for specific scenario. Basically, all sorts of coursework are going to be based on scenarios based, situational. You're going to be have given a scenario, and then you have to create solve the problem and based on the question. Okay, are we clear so far? Any questions? Hmm. Okay, I still cannot hear you. Never mind. No. All right. Good. Thank you. Okay. So basically, evaluations or assessment of students are based on Bloom Bloom taxonomy. Okay. So this is where you have all the C5, C6. Okay. Those basically to see your your stages of your progress, self progress, whether or not the students are able to produce new or original work, you are able to describe with your own words what you can understand. Okay, that's how we evaluate or assess. Right down to recalling facts and basic concepts which has been delivered during the lectures. Okay, all these are essential for students. So basically, the Bloom taxonomy state that a student needs to be able to remember, understand, apply, analyze, evaluate, and create uh, relevant information or convey information what they have been conveyed during the class. Okay. All right. So this one also applies to the assessment, psychomotor domain. Okay. You are able to articulate, manipulate, imitate. Okay, all that um, factor for this section. If you're able to do that, then it is going to basically fulfill what needs to be learned. The outcome needs to be achieved for this particular section, this particular course. Yeah. Okay. So these are also another affective domain which is relevant to assessment. So now this is the next thing. course assessment weightage. So we have here a component of coursework. Coursework basically is given calculated as 70%. You contribute 70%. It basically contributes 70% to your final mark. And then you also have final online assessment. Okay, maybe somewhere around week 7, week 8, perhaps you have. I'm not really, I haven't really have any information about this, but this can be communicated within or along the course where as we move along. So, but anyway, the final online assessment contributes about 30% to your final mark. Yeah, so that is under FOA. So that's total of 100%. Okay, so each student must obtain about at least 40 to 100, over 100 marks in the FOA in order to pass the course. Yeah, 30% out of this 40 over 100. Okay, that means 30%. So very important. I believe this course is, I'm not sure if you have probably been exposed to or been already learned something about data structures and algorithm. Have you? When I give you lecture notes, did you actually download the notes? Have you downloaded the notes? Noel and Calvin, did you guys download? Yes, okay. Did you actually browse through the notes and look through and read through? Understand? Okay, yeah. So it's quite long, yeah. So maybe what we can do is we can I will explain step by step slowly, and then you can also share whether or not you can understand. Okay, you are in semester 3, yeah. You guys are in semester 3, 6, what is 6? So should be well aware or well versed with all the content of each courses as well as a programming part and all that. Yes, no, yes. Okay, good. Okay, next one. So this one is coursework formative assessment. These are the skills. These are the components that are going to be assessed to each student. Okay, cognitive application section. Component pre-practical questions or quizzes, which is going to be given during the practical classes. So that is basically ungraded, but during the class you are given 10%. Okay, for practical skills, which is applied during your assignment or on your assignment. Um, please be aware that during your assignment, when you're given assignment, you are supposed to maybe um, present your assignment during the class. Yeah, so that practical, which is one is the assignment itself, is 80%, and then communication skills, the way how you present it, will be another 10%. Yeah, so important notes here: students are required to obtain a pass mark of at least 42.5. Yeah, for the CLO2 under practical skills, which is the entire assignment to pass your coursework. Okay, so this is our main references: a textbook, Introduction to Java Programming and Data Structures, 11th edition by Pearson. Okay, and then published by Pearson. Yeah, another one is the Object-Oriented Data Structures using Java, 4th edition. Okay, so basically, as you know, we are actually using Java. So maybe later on during our practical session, we have to do a little bit of installation if you haven't installed already. Okay, let's just try to install, and then after that, we'll give you a code to test on. Okay, okay. So another part is that this one. This one is your cost plan. Cost plan is basically showing you topics which we are going to cover for each of the week after week of lecture. Okay, there are, as you know, there are 14 weeks. Okay, for this semester. Yeah. So for today, day class, we are going to cover a lecture on applications of abstract data types. And then after that, also practical on application of abstract data types, which is referring to the sample source code, which will be shared. Okay, I hope you are able to do this later on, which means a successful installation and won't face any other problems. And then we can proceed with sample source code practice. Okay, so for week number 2, it's also a continuation of the application of abstract data types, ADTs, on ADTs specs. Yeah. So then we have the also goes to practical ADT specs as well. Because if you browse through your notes, it is a very long notes on topic number 1. So that's how I feel like they separated this into 2 sections, week 1 and week 2. So you are able to really capture what is the concepts and all the essential things that you need to learn about ADTs before we move on to the next section. Yeah. So and next one is week number 3. We're going to go for efficiency of algorithms, array-based implementation of the ADTs. Okay. Lecture 4, array-based as well, continuation. And then lecture number 5, you are going to still continue on array-based implementation. And each of the week, you're going to have 2 classes, which is the lecture as well as the practical. So each practical classes will have a sample of source code for you to try on, and then we'll see and analyze the code, what the functions are and all that, which apply to the lesson which we learn in the class. Week six, if you can see here, we have linked implementation of ADTs. Okay, so linked list. Okay, and then week 7, recursion. Next, sorted list, and then algorithm for searching, algorithm for sorting. Yeah, and then after that, binary trees on week 11, and then last but not least, hashing on week 13. And then by week 14, we are supposed to basically do a revision, because after that, you're going to have exam. After the whole of your lecture your syllabus has been completed. Okay. Okay. So any questions? No. Okay. Thank you. I am still trying to wonder. I'm still wondering what is the problem with. I cannot hear you. Hang on. Maybe I can change this. Location. Speakers. Hang on a sec. Yeah. Let me do some modification. Speakers. Maybe I did not turn on the volume. Okay, so for no questions, yeah, okay, good. Yeah, in the meantime, we just sort out the volume problem, yeah, so that everybody can participate in the discussion. Okay, in the meantime, I want you to browse your notes for a second, yeah, browse through your notes. Okay, so we are going to go to our lecture notes now. Okay, so this is chapter one. For chapter one, we are going to go for application of abstract data types. First, revisited on this learning outcome. At the end of this course, you should be able to explain the benefits of abstraction. Okay, I'm going to turn off my cam so that the system is not too heavy for me here. Okay, in the meantime, you can probably try to speak. Maybe my system will support that volume again in a second or so if I stop this video. Okay, never mind. We continue. Learning outcome for this course is at the end of this lecture, you should be able to, as I mentioned earlier in the introduction, explain the benefits of abstraction. So that is application of your knowledge under this topic. Apply the use of list, stack, and queue, and then ADTs appropriately to solve problems. Okay. Uh, Next one. So this is a recap of your programming paradigms. As you know, there are many programming paradigms that is available. You probably know this. Yes, do you know this? Have you encountered this before? Procedural paradigm and object-oriented paradigm is an idea about procedural programming and object-oriented.
Yes.
Ever encountered this word before? Noel, Calvin? Yes, good. So it should be easy for you to learn then. Okay, so which came first? There are many the structure, the arrangement of the language paradigms. Yeah, which came first? Procedural or object oriented? Which one? Yes, correct. So procedural basically came first before object oriented. Yeah. I believe you have a bit of knowledge on this procedural. Can Calvin explain to me or the class what is procedural? Calvin, what is procedural? Okay, never mind. Feel free to answer. Yeah, feel free to answer. Yes, exactly. So basically, procedural is done in steps. Okay, step one step after another. That's why you call it procedural, right? Okay, and then while object oriented is null, uses object. Okay, so object oriented basically. Okay, first thing you have unstructured. Okay, let me brief you go like guide you to go through the whole paradigm in brief first. Yeah. Okay. First thing, when you do a programming, first time long ago when a programmers want to do programming of software and in the software engineering field, so they have this paradigm called way long time ago. It's called unstructured. Yeah. So meaning all the syntaxes and the programs and the functions of the programs all jumbled up together, making it really inefficient to function because as you go along, you tend to add more modules into the program. So it gets longer and longer and longer, and also applies redundancy. And then it is too long to be manipulated. It is too complicated to be manipulated. So then it goes, after that, they evolve into procedural. Procedural is done step by step, as Calvin is saying. Okay, so procedural means that you do one procedure after another. Uh, like if you want to explain one procedure, you make up one particular construct, one particular code for that. So it has many procedures in one particular program. Then after that, same goes with that. There are many procedure. You can call procedure one after another. Okay, turn by turn. Then after that, the programmers think that maybe we can actually cluster them together and make them into one functional body that has procedures inside that works one after another. So you call that object-oriented programming. Okay, so then it is easier. Object-oriented means you can call any sorts of functions. In the function itself, there are whole sets of modules in there which they can call. Okay, and then it makes it easier when you want to call certain functions that you just call. You don't have to write redundant program. So it is quite reusability, and it is efficient. Promote usability, I mean. Okay, so this is your terminology which you use, grouping of codes which you have inside your object oriented. Okay, modularity, encapsulation, information hiding, and abstraction. So what is it? So are they present in both procedural and object oriented paradigm? Why are they so important? Let's see. So basically, modularity can be defined as mechanism where a complex system is divided into several components. You call it modules, right? So, like I said, whenever you want to create a program, it is essential that you have modules by modules. All the programs are clustered in one modules, another modules which perform different functions, so that when a customer basically requests you as a programmer to develop certain software, we can use or integrate the whole of the modules which basically form a software that is required by our stakeholders, the customer. So this is just like when you go to an ice cream store, you have many kind of flavors for your ice cream. Okay, and then the customer say, I want this kind of flavor mixed together with that kind of flavor, and then that produces a product that is liked and preferred by that particular customer. So that is how you pick strawberry ice cream and you pick vanilla ice cream and put it into that particular cone for you to enjoy. That same goes with this, that are called modules. So another example is that we have been playing Legos to build different structures as a kid. Not only kid, even adults probably. It is very soothing. It is really relaxing. You are stressed. You just probably built it. It requires attention, focus, okay, motivation to construct. Okay, so here we have several components, blocks which we integrate to build structure that you want. Okay, that is called modules. Yeah, as an analogy. Okay, so that is modularity. Modularity. Next one is encapsulation. What is encapsulation? Refers to bundling. You want to encapsulate. You want to cover one particular data which has methods that operates the data into a single unit. Okay, so encapsulation in Java is performed using a class. So, for example, in your program, you want to that consists of certain many classes that has programs execution in each of the classes has performed it perform different functions. So a class basically wraps code on the method and the data which are referring to variables together. So this concept ensures that data members of a class are always hidden from the other classes. Okay, we can only access those data members using methods. Okay, for example, I put here I illustration of how encapsulation works. So you have look at the pale looking diagram image here. This whole pale looking image here is referring to a class. In the programs, there are many classes. Each classes has their own variables and the methods on how that particular class works. Okay, so this is your code on how you actually write your codes, the codes for class and what are internal, what revolves, what are happening, what is happening inside your class. Data members plus methods. Okay, how does that particular class behaves? Okay, next one. Then we have information hiding. So a while ago you have encapsulation. Next you have information hiding. Okay, so information hiding is I give you example. It's like if you a developer, a car manufacturer, they want to build a car for the customer, but they want to hide certain information about how the car functions, internal programs on how the car functions. So customer can only see the outer interface of that particular car, which means the screen on how the car should function, the music operation, and how the car moves, how you drive it. Okay, that's you, so that there won't be any other information that can be changed. If you are a customer, you don't actually have to know that kind of thing. Okay, information hiding is the principle of segregation of the design decisions in computer program that are most likely to change, thus protecting other parts of the program from extensive modification in the design decisions that change. So, okay. Mhm. Any questions so far? Noel?
Nope.
No. Are we okay so far? Okay? Yeah. Okay. Okay, now, what is abstraction? So, abstraction is basically what? Abstractions are these, which consists of integer, concept of object-oriented programming that shows, okay, only essential attributes, okay, and hides unnecessary information. Yeah, so my main purpose of abstraction is hiding unnecessary details from the users. Okay, so you select data from a larger pool to show only relevant details of the object to the user. Right, so this is abstraction, almost similar to encapsulation, yeah? Okay, so look at this image. You want to hide implementation details by providing one layer over the basic functionality. This is the implementation of your CPU. This is CPU, I believe. Yeah, CPU. So a customer, when they, not the CPU, it's a PC. Yeah, it's a PC. Yeah, yeah, monitor. So basically, as a customer, developer wants you to only see what customer can see is only the interface on an operation that a computer can perform. And implementation works inside the system. Okay, all the components which is inside the product itself, which is referring to the computer. And then how does that particular system or what function moves and how is the computer works is hidden, so it's encapsulated. Okay, so abstraction referring to how it looks to the customer interface and operation. Encapsulation is how the operation works, what function is triggered when a customer press a certain icon, for example. So that kind of details are hidden. The methods which triggers which are called by the functions which are written in the program. Those are hidden. So you call that encapsulation. So this one benefits probably is the listed here. User can focus on the big picture. Big picture means I want that product. I want to see only how the product function. I want the product to function exactly on how I want it to be without knowing what is happening inside internally in the system and the programs itself. So that is the job of the customer. The customer only want to see the outer layer, which is the interface and operation, which supports what they need. Okay. Developer can modify the class implementation without affecting the user based on requirements of the stakeholders, which is referring to the customer. Okay, so this is a benefit. Okay, so this is the design principles of encapsulation. Different components of a software system should not reveal the internal details. Okay, so you call that uh, hiding of information hiding. Programmer has freedom in implementing the details of the system. Okay, because nobody needs to see the inside. So, how it works, it is my what I will design. Okay, so only you, therefore, you have a freedom. Okay, programmer only needs to maintain the contract interface that outsiders see. How it should be done, what method, what classes to be put in, what function to be called, and how does it is going to be done is based on the programmer. The customer can only, not can only, the customer should only know what they want, which is how it look like, the interface, the function works as they want it. Okay, so that is flexible to both party. Yeah, both party means um, programmer and the user. Modularity. Organizational principle for code in which different components of a software system are divided into separate functional units, module. Just like when you want to plan your kitchen, you want to design your kitchen, right? So we have this company called here in KK, I think it's which produce modular kitchen cabinets. So basically, if a customer wants to design their kitchen based on their requirements. Sometimes they don't need certain things, so they can just pick which particular modules of the kitchen that they needed. So they can go to that modular kitchen provider or manufacturer. Same goes with this one. Uh, Organizational principle for code in which different components of a software system are divided into separate functional units, modules. Why? Rationale is modern software system consists of several different components that must interact correctly in order for the entire system to work properly. So keeping this interaction straight requires that these different components be well organized. Okay? Modularity, which relates to the concept of working together. Each module works together to achieve a certain function which are required by the stakeholder, which is referring to the customer. Okay, so design principles of abstraction. to distill a complicated system down to its most functional parts and describe these parts in a simple, precise language by naming the parts and explaining their functionality. Okay, this is design principles for abstraction. So maybe you just need to know about what is the principle of each term. Yeah. So here I have video in brief about data structures. We can have a look at this one.
Hello and welcome to this new series on data structures. In these first few videos, I want to lay the foundation of some core concepts you will need throughout these video tutorials. Let's get started with the basics. So, what is a data structure? One definition that I really like is a data structure is a way of organizing data so that it can be used efficiently. And that's all a data structure really is.
Just
It is a
remember
way of
what is
organizing
definition of data
data in
structure.
some fashion so that later on it can be accessed, queried, or perhaps even updated quickly and easily. So, why data structures? Why are they important? Well, they are essential ingredients in creating fast and powerful algorithms. Another good reason might be that they help us manage and organize our data in a very natural way. And this last point is more of my own making, and it's that it makes code cleaner and easier to understand. As a side note, one of the major distinctions that I have noticed from bad, mediocre to excellent programmers is that the ones who really excel are the ones who fundamentally understand how and when to use the appropriate data structure for the task they're trying to finish. Data structures can make the difference between having an okay product and an outstanding one. It's no wonder that every computer science undergraduate student is required to take a course in data structures. It is strange that before we even begin talking about data structures, that we need to talk about the abstraction of data structures. What I'm talking about is the concept of an abstract data type. What is an abstract data type and how does it differ from a data structure? Well, the answer is that an abstract data type is an abstraction of a data structure which provides only the interface to which that data structure must adhere to. The interface does not give any specific details on how a specific data structure should be implemented or in what programming language. One particular example I like to give is to suppose that your abstract data type is
To
for a
voice.
mode of transportation to get from point A to point B. Well,
What happened, Noel? You hear two voice? Two voice means? Um, okay, wait.
as we both know, there are many modes of transportation to get from one place to another. So, which one do you choose? Some specific modes of transportation might be walking or biking, perhaps even taking a train, and so on. These specific modes of transportation would be analogous to the data structures themselves. We wanted to get from one place to another through some mode of transportation. That was our abstract data type. How did we do that exactly? Well, that is the data structure. Here are some examples of abstract data types on the left and some possible underlying implementation on the right hand side. As you can see, a list can be implemented in two ways. You can have a dynamic array or a linked list. They both provide ways of adding, removing, and indexing elements in the list. Next, we have a queue and the map, abstract data types, which themselves can be implemented in a variety of ways. Notice that under the implementation for a queue, I put a stack-based queue because, yes, you can have a queue which is implemented using only stacks. This may not be the most efficient way of implementing a queue, but it does work and it is possible. The point here is that the abstract data type only defines how a data structure should behave and what methods it should have, but not the details surrounding how those methods are implemented. That is all for this video. Thank you for watching, and in the next video we will be talking about computational complexity and big O notation.
Okay, so that's briefly about data structures. Are we okay? Can we understand? Yeah, okay. Now let's move on. So this is already been explained a while ago. The implementation of abstract data types, um, often referred to as data structure. So using some construct and primitive data types. Okay, so it's just how you arrange the data so it can be used efficiently, abstract data type. Okay, so your abstract data are basically data types. For example, that it has, okay, for example, you have array, list, map, queue, set, stack, table, etc. Okay, about which we're going to discuss in a second. Okay, so this is basically your abstract data types, which we are going to go deeper into the topics today. Consists of data that has certain characteristics together with a set of operation that can be used to manipulate the data.
Hello, and welcome to another video. Today we're going to try and understand the concept of an abstract data type, also abbreviated as an ADT. This was quite a confusing topic for me when it was first introduced, but understanding abstract data types has made many other computer science topics easier to understand. Before jumping right into it, let's hit the rewind button first and make sure we understand some simpler structures. For this video, I'll discuss these in the context of Java. We can start off with our very basic primitive data type. In the context of Java, there are 8 primitive types, and if you're new, you'll probably have at least seen the integer, double, character, and boolean. Just in case you're wondering here, strings actually refer to objects rather than primitive types in Java. So, what's special about primitive data types? These are our data structures that cannot be broken apart into simpler structures of data. They're essentially the building blocks for more complex data structures. For example, let's take a look at a linked list here that holds integers. The linked list itself is not a primitive type because it can be broken down into the individual integers it contains. However, once it's been taken apart into its constituent integers, it cannot be simplified any further as integers are one of our primitive types. So now we can move on to our user-defined types. User-defined types allow us to create our own data types, so we're not just limited to those 8 primitive types. In Java, we can make these using classes. A class holds a set of behaviors, which you may know as instance methods, and a set of characteristics, which you may know as instance variables. Let me show you what I mean. Let's consider the person class, which we're using to make the user-defined type person. Our person type, just like any real person, can have a set of characteristics and behaviors. In this case, let's say our characteristics are a name, an age, and a salary. These are the instance variables for the person type. Next, we can have a set of behaviors, perhaps a work behavior and a sleep behavior. These are our instance methods. A great option we have when we make user-defined types is inheritance, where one class can inherit another class. For example, if I made a new class called employee that inherits the person class, then the employee class can have access to everything from the person class. This also means that an object of type employee is also of type person. The concept of an object having multiple types is known as polymorphism and is a very important and powerful tool in object-oriented programming. Now we're ready to talk about abstract data types. First, let's address what we mean by abstract. Abstraction refers to us hiding the complexity of a system underneath some higher level or more general idea. Take the stack abstract data type. Let's take a quick second to recall that a stack is a linear structure operating on a last in, first out basis, just like a stack of books. Stacks can be implemented using an array or linked list and have the methods push, which adds to the stack, pop, which removes from the stack, and peek, which shows you the top value of the stack. But what makes a stack abstract? Let's say we choose an array to implement the stack. Well, the stack itself is simply a concept based on the behavior of the underlying array structure. To use the push method, we do not need to know whether the stack's underlying structure is an array or a linked list, and we do not need to know how the push method was implemented. This adds a layer of abstraction between the concept of a stack and what it actually is in terms of implementation. There are many other examples of abstract data types relying on some underlying structure. For example, the stack and queue abstract types can both be implemented by a linked list. As you know, a queue behaves differently from a stack, even though their underlying structures are the same. The difference lies in the methods implemented on that linked list. A graph can be implemented using a 2D array, also known as a matrix, and a binary tree can be implemented using an array as well. So why do all of these data types matter? Well, we can have a stack containing primitive types, but this certainly is not always the case. Abstract data types can house our user-defined types. A rather unfortunate example would be a company laying off some of its workers on a last hired, first fired basis. Now we'd have a stack containing employees and someone calling the pop function on the stack. Again, the user does not need to know how pop works or whether the stack is using an underlying linked list or array structure. The abstract nature of the stack hides its complex details underneath the broader idea of the stack structure. If you've made it all the way to this point in the video, I hope it's been helpful to your understanding of this concept. It can certainly be quite a bit to wrap your mind around, but once it clicks, it's actually really cool. Don't forget to like, subscribe, and let me know what you'd like to see next in the comments down. Hello, and welcome to another
Hello.
Oh boy, you cannot hear me. Oh boy. Okay, okay. Sorry, I was talking. All right, never mind. Sorry about that. All right. Okay, so these are examples of abstract data types. You have integer, and you have double, string, fractions, and counter. Okay, these are the examples. You know what are these, right? You use this to basically um, define your data, abstract data types in your program. So you call integer, referring to the numbers. Okay, string, referring to the a set of characters, and etc. So collection of ADTs, abstract data types. Basically, it's a general term for an ADT that contains a group of objects inside your program. So some collection allows duplicate items, some do not. Some collections arrange their contents in certain order, while some do not. These other collections, why are they, how are these collections different? So basically, this is depending on what are they made of, what are their functions, what are intended for. So okay, this for example, A, B, and C, each has their own functions. Okay, the purpose of A to queue, the people and the around here are queuing for food, and then it has many kind of people, many people here. But there are a lot of people here who are trying to queue up for certain food, which basically their purpose is to find food. Okay, so and then B is a is basically looking at the description of site and drinks in a menu, which has different data types involved. Okay, and then also C is a collection of um, bread, which has different characteristics. Okay, algorithm is a list of steps to solve a problem or to perform a task. There are different algorithms may be used to solve the same problem. Okay, there are many algorithms that you can use to solve the same problem. You can write certain algorithm to define what method, not method, what function it performs based on the requirement of a customer. Okay, so look at the illustration here. You have two different products, McDonald's and Subway. So both actually a fast food chain that basically want to give a product to the customer of fast food. Yeah, both are delicious. So what are the resources? The resources which consist of this materials you see here: onions, capsicums, cheese, and sausages. Both has that probably. McDonald has different kind of resources and how long it can produce. Okay, so that requires all the specification, requires algorithm. to define how long you can actually perform, how long can you prepare certain fast food to basically satisfy your customer needs. There are certain steps that are involved to basically produce certain products. Okay, so algorithm basically determines time efficiency, the time taken to complete a task, and then the use of it program. And this one types reusability, maintainability. Okay, reuse means you can, if you see earlier on, we look into the abstract data types. There are many kind of types of entities inside your programs. Programs that has modules, after modules, okay, and then which you can actually cater based on the requirements of the customer, reusability, and you can maintain that based on a concept where you keep all these data types inside of your programs where it performs certain functions which satisfy the need of your customer. Okay, and then all these are easy to maintain because it is there won't be any redundancy involved because you have basically defined it in your system based on the what abstract data types are required for certain functions. Okay, now this is collections. A collection is a general term for an ADT that contains a group of objects. Linear collection or is a collection that stores its entries in a linear sequence. Okay, what is a linear sequence? Anyone knows what is a linear sequence? Kelvin? No? What is a linear sequence? Yes, correct. So sequence is none other than a orderly manner of one, two, three. Yeah, stage one, two, three, four. Okay, that is one after another in order. So examples of linear collections are list, stacks, queues. That comes basically people queuing up a while ago. The sample example we saw a while ago. People are queuing up. One, you cannot proceed to the next person until the other person is served. So that happens in list, stacks, and queues. They differ in restriction they place on how these entries were added, removed, or accessed. That means maybe in the lecture, the description on how each of these collections are described. For example, there will be a concept of LIFO, a concept of FIFO. LIFO is last in, first out, or FIFO is a first in, FIFO, first out. Yeah, so we're gonna look into that in a second. Okay, this is your list. List is a collection of items in which the items have a position. A linear collection of entries in which entries may be added, removed, and searched for without restriction. So this is inside your code. You use this kind of list abstract data types. So these are the function or basic operation performed by list. Yeah. So here add E. So simply means that insert element E at the end of the list. Okay, these are the function. Remove I simply means remove the element at position I from the list and return to this element. Is empty. Okay, return true if the list is empty. get I, return the element at position I in the list without removing it. Clear simply means that to remove everything from the list. And so the list is empty again. So application of list is to list of tasks, to list of names, to playlist. So when you write a program, you use this basically to list down the things that you want to be included inside your program. Okay, list names, and then list uh, uh, instructions. Okay, so and uses high precision arithmetics to represent very long integer values. That's why you call it listing. Okay. So to illustrate the use of collection of ADTs, we will use a predefined Java interfaces and classes from the Java collections framework. Okay, uh, and in chapter 4 onwards, you will learn how to create your own collection of abstract data types. So these are the Java collections framework, which you get from the Java utility list in your installation tool. Okay, so Java utility list interface, you have all these characteristics: return type, method, and description. Okay, get index, integer index, returns the element at the. Okay, this is what you have already been exposed, been informed here. This one. Okay, this is a from the framework utility. Okay, these are return type: boolean, void, and boolean. So boolean at e, this is looking at integer index e element, inserts the specified element at the specified position in this list. Okay, that is about void. Clear also uses the same type of collection, Java collection framework in the Java utility list, is to basically removes all the elements from this list by using this clear. Okay, boolean contains object O, returns a true if this list contains a specified element. So if you see that with boolean, that means that refers to this E. Okay, get returns the element at the specified position. This one we've done it already. Yeah. This is your example. Okay, look at this interface, Java utility list. Okay, what does that particular line means? Okay. For example, I'm just gonna read out first example. The rest you please, you can actually go through again and read. E element. Hang on. Sorry, I didn't see your comment just now. Yeah. Okay. At E, it's a method and description of. It's specified maybe a what do you call this? They call, how do I describe that? Entity that they use in this program. Get integer index. That E means get integer index. That specific E word refers to get specific integer index. Okay, returns the element at the specified position in this list. This is basically what E means. Okay, integer index. Remove. You notice at E. At E means append the specified element to the end of this list. E element, insert the specified element at the specified position in this list. E get returns the element, basically referring to element. Remove integer, remove the element at the specified position of this list. So that is basically referring to element, yeah? If you can see the connections between the return type and also the method and description of what it should be doing. So basically referring to element. So when you see this plus add index integer element E boolean, so basically that is an instruction to add a new element at the specified index. Second one, plus add all index into C collections, less or maybe extend to E. It goes to boolean, so adds all the element in C to this list at the specified index. Okay, so please go through this one. And then after that you have array. Maybe we can go through that array first, yeah. Okay, so this is a sample code which we are going to maybe do in later during practical. First thing, I just need to ask, yeah, have you guys installed, actually have the what do you call that, NetBeans and the JDK installed, Java JDK installed in your system? Oh yeah, oh good. So both of you has installed both NetBeans and the JDK, yeah? So what is the version of your NetBeans and your JDK, may I ask? Do you know what is the version? Which one is this? This is your NetBeans? Your NetBeans, no, you're not. NetBeans is a version 8.2. Hmm. Oh, okay, that's quite old. Huh? When did you install that, by the way? Oh, okay, it's quite old. Because what I have here is actually a NetBeans 12. Last year, June? Hmm. Okay. So last year, okay. Because what I have here is a NetBeans 12, and JDK, NetBeans. Hang on, let me see. NetBeans 12 and JDK 12. What about your JDK? Your Java? What is the version of your Java? Do you know? Yeah, please, you can check that into your in your command prompt. Okay, have you have you ever made a program before? since you have that NetBeans installed as well as your um, JDK. Yes. Oh, okay, good. That means it should be easy for you. Okay. I'm not really. I don't. I'm not sure which level are you about. So okay. Later on, what I do with you guys is that my system is I have just what do you call that? Um, reformat my laptop, so I don't have that IDE installed yet, but I have my Java installed. So what I can do is maybe I will give you the code later on, okay, for you to try in your respective um, station, and then you tell me if that perform a certain function that it should be. Okay, and then what I will do during the practical later on as well, I will give you the questions for you to attempt. Okay, in the meantime, I will try to install my have all of my systems set up. Should there be any problems faced along the way, is that okay? Okay. Okay, so let me see how long are we still. Let's see. Are we near? Type of code is here. Okay, so this one actually going to be given to you as well later on. Runner.java, registration.java, whichever is applicable, whichever that you can. So, yeah, okay. So, yes, you don't have to do that. Maybe what you can do, that's why I plan to give you the code to see if that works with your version. But I suspect that it probably works with yours. But I'm not sure, yeah. But that's why I said maybe you can try on with the codes which I'm going to give later on during the practical. So if we face any problem, then we can try to resolve that. Maybe I'm not sure how many. Um, what is the size? What is the size of your NetBeans? Because I hope that it doesn't actually what you call that counter react with what the new one is going to be if you were to install it. But first, we need to test the current available NetBeans and your JDK whether it works with the code. I suspect it will work. Okay. Okay. Later on, I hope my system will work to hear you talking. It's very hard to actually see the chat room while I'm talking here, but never mind. Let's see, yeah, how long? Type of list, text. Mm, okay, a little bit more. Still have time, yeah. I can finish up. Yeah. Oops, sorry about that. Oh, goodness. Okay. There are quite a long way to go here. Stacks, queues. Hmm. Okay, never mind. We will cover what we can cover for today. Okay, because we are going to end at 11, right? So we can cover until. We just go on, right? Proceed. Okay. So there are types of list. Now we are covering list, and the second we covered stacks, and then there will be queues. So here are the types of list. Yeah, we have unordered list, meaning the order, obviously the order of the list is not in a range in order. So by default, that's why it's called list to an unordered list. List refer to unordered list. Unordered list. Yeah, that's why you word unordered list. Next one is the ordered list. So as you know, concept is ordered list means all the entries are maintained in a sorted order 1, 2, 3, 4, 5. Okay, we will cover sorted list in chapter 7, but so this is just a brief explanation, brief exposure to lists. Okay, next one. Now stacks. What are stacks? Stacks is just stacking something on top of the other, a collection of objects in which the objects are inserted, removed according to the last in LIFO principle. So whatever you stack, the last in, last in will be the first out. Okay, a collection of objects in which the objects are inserted and removed according to the last in, first out LIFO principle. Okay, a linear collection of entries in which entries may only be removed in the reverse order in which they are added. That's why you called it LIFO, last in, first out. Okay, so they can only be removed in the reverse order in which they are inserted in. Last in, first out. Yeah, so for example, if you want to stack up your documents, like you want to submit your documents, you stack one into a basket of your document basket, and then you stack another person submit, another person submit. So but this concept is the lecturer will not be marking the one who submitted first, but she will take the one that is the last entry. The last one means the way top part of the assignment. Okay, so this is stacking. So typically there is no provision to search for an entry in the stack. So it is that's why it is not really flexible, because whenever an entry is inserted, it can only uh, taken out in a reverse order. So this is stacking. Okay, this is another video. It's a very simple video.
May I begin by saying that the stack is a remarkable, absolutely remarkable data structure. One of my favorites, in fact. This is part 1 of
Okay, I'm
3
gonna
in the
on my
stack
voice. Sorry about
videos.
that.
Part 2 will consist of looking at a stack implementation, and part 3 will be some source code for how a stack is implemented using a linked list. So here are the topics that we'll be covering in this video as well as the others. First, we will answer the question about what is a stack and where is it used. Then we will see some really cool examples of how to solve problems using stacks. Afterwards, we will briefly look at how stacks are implemented internally and the time complexity associated with the stacks operation. And lastly, of course, some source code. Moving on to the discussion about stacks. So what is a stack? A stack is a one ended linear data structure, which models a real-world stack by having two primary operations, namely push and pop. Below you can see an image of a stack I have constructed. There is one data member getting popped off the top of the stack and another data member getting added to the stack. Notice that there is a top pointer pointing to the block at the top of the stack. This is because elements in a stack always get removed and added to the top of the pile. This behavior is commonly known as LIFO, or last in, first out. Let's look at a more detailed example on how a stack works and how things are added and removed from a stack. So let's walk through an example. On the left side, I have some instructions on what we need to add and remove to the stack. So the first operation is a pop. So we remove the top element from the stack, which is apple. So boom, apple is gone. Now we push onion onto the stack. So we add onion to the top of the stack. Next instruction says to push celery onto the stack. Next is watermelon, which we put on top of the stack. Next operation says to pop, so we remove the element at the top of the stack. This is the watermelon we just added. The next operation, also a pop, so we remove from the top of the stack. This is celery. And the last operation, push lettuce onto the stack. So we add lettuce on the very top of the stack. So as you can see, everything operates on the top of the stack. We don't have access to anything else but the top of the stack. This is critical in our understanding of how a stack works. So when and where is a stack used? Stacks are surprisingly used absolutely everywhere. They're used in text editors to undo text you've written, in browsers to navigate backwards and forwards. They're used in compilers to make sure you have the correct number of matching braces and in the right order. Stacks are used to model real-world stacks such as books, plates, and even games like the Tower of Hanoi, which we'll get to shortly. Stacks are also used behind the scenes to support recursion by keeping track of previous function calls. When a function returns, it pops the current stack frame off the stack and rewinds to the next function that is on the stack. It's rather remarkable that we use stacks all the time in programming and never even notice it. Something else you can use stacks for is to perform a depth-first search on a graph. A depth-first search can be done manually by maintaining your own stack or by using recursion. Well, guess what? Both use stacks, as we have just discussed. Complexity analysis. So the following complexity table assumes that you implemented a stack using a linked list. Pushing takes constant time because we have a reference to the top of the stack at all times. Well, the same argument goes for popping and peeking. Searching, however, still takes linear time. The element we're searching for isn't necessarily at the top of the stack, so we may need to scan all the elements in the stack, hence requiring linear amount of work. Now, here's a cool example of a problem using stacks. Problem. So given a string made up of the following brackets, round brackets, square brackets, curly brackets, determine whether the brackets properly match. So analyze the examples below to understand what type of bracket sequence is valid and which ones are invalid. So before I show you the solution, try and come up with a solution yourself. Hint, use a stack. Okay. In this first example, consider the following bracket sequence. As we are processing the string from left to right, I will be displaying the current bracket and the associated reversed bracket. So let's begin. For every left bracket we encounter, we simply push those on the stack. So this is a left square bracket that I've highlighted in light blue. So we push this one on the stack. Same goes for the next left square bracket and for this left curly bracket. Okay, this is a right square bracket. So we encountered a right square bracket. So we need to do two checks. First, we check if the stack is empty. If so, the bracket sequence is invalid. But if there are still things in the stack, then we pop the top element and check if its value is equal to the reversed current bracket. Right now, the top element is equal to the reversed bracket, so we are good. Next is a right square bracket again. So is the stack empty? No, it isn't, so we're good. Is the top element of the stack equal to the reversed bracket? Yes, it is, so let's keep going. A round left bracket. Let's push it onto the stack. A right bracket. Is the stack empty? No? Okay, so we're good. Is the top element of the stack equal to the reversed bracket? Yes, okay, so we're good. Another right bracket. Is the stack empty? No, okay, good. And is the top element of the stack equal to the reverse bracket? Yes, okay, good. And now we're done processing the string. We need to make sure the stack is empty now. Why is that? Well, in case the last few characters in the bracket sequence were left brackets, they would still be in the stack, right? But our stack is empty, so we can conclude that this bracket sequence is indeed valid. All right, let's do another example with another bracket sequence. So try and work this one out. So the first bracket is a left bracket, so we push on to the stack. The second bracket is also a left bracket, so we push on to the stack. This next bracket is a right bracket, so let's check if the stack is empty. No, it's good. And is the top element of the stack equal to the reverse bracket? Yes, it is. This next bracket is a right bracket. Is the stack empty? No, so we're good. And is the reverse bracket equal to the bracket at the top of the stack? No, it isn't. So this bracket sequence is invalid. So here's the pseudocode of the algorithm we just ran through. So if we let S be a stack, then for every bracket in our bracket string, we can get the reversed bracket for that current bracket easily. So if our bracket is a left bracket, push it onto the stack. Otherwise, we check if the stack is empty and if the element at the top of the stack is not equal to the reversed. If either of those conditions are true, then we return false. Otherwise, we return whether the stack is empty or not. And if it is empty, then we have a valid bracket sequence. Otherwise, we do not. I want to take a moment and look at the Tower of Hanoi, a very popular game amongst mathematicians and computer scientists, to see how it relates with stacks. The game is played as follows. You start with a pile of disks on the first peg on the left, and the objective of the game is to move all the disks to the rightmost disk pile. At each move, you can move the top disk of any pile to any other pile with a restriction that no disk be placed on top of a smaller. So we can think of each peg as a stack because we're always moving the top element in a peg and placing it on another peg. So shall we play? I will let the animation run and you will see how each peg acts like a stack. It's pretty cool. So you just saw how transferring elements from one peg to another is exactly the same as popping a disk from one stack and pushing that same disk onto another stack given that the disk you're placing on top is smaller. So that's really cool. All right, in the next video, we're going to quickly look at how a stack is actually implemented. If you're interested in some actual source code for a stack, that can be found at the link at the bottom of this slide. I will also be going over the source code for a stack in the last. May I begin by saying that the
Okay, so that is the illustration of what stack and how stack function in the system. So these are the basic operations of stack. We have push, E element. Yeah, pop and is empty to check whether the stack is empty. Okay, peek to check whether the traffic is clear to move the stack without removing it. Return to the top element in the stack without removing it. And last but not least is clear to remove all the elements from the stack so that the stack is now empty. Okay, so these are the basic operations. Have you used this operation before? Push pop is empty, peek and clear in your OOP. Yeah. No. Maybe you're not aware. Probably you have used, but certain functions has that stack. Okay, stack trivia. This name stack is derived. Basically, this is just extra information. Yeah. Name stack is derived from the metaphor of a stack of plates in a spring-loaded cafeteria plate dispenser. So, based on these concepts, they came up with the word stacking. You look at the plates which has been kept in the plate dispenser. Whichever plates comes in first will be the last one to come out. So the first one, last in, first out. LIFO. Okay.
welcome to
Okay, so this is a stack implementation. This basically not defines, illustrate on how, what is the next slide going to be. We have slides which illustrate how stack implementation is. What I'm going to do, because we are coming to an end, do you want to watch, because this is basically explaining on how stack is being implemented. Do you want to watch the video or you want to see the slides? So you want to see the slides? Oh, video. Because if you see the slides, they are a long illustration, very long-winded, but maybe you can see the stack implementation in a brief explanation. Yeah. Okay. Let's just watch this one, so you can we can at least save time on watching on the slides. Okay. Let's watch this one.
part 2 of 3 in the stack series. This is going to be a short video on one way to implement a stack.
Sorry, I'm gonna turn up my mic.
So stacks are often implemented as either arrays, singly linked lists, or even sometimes doubly linked lists. Here I will cover how to push nodes onto a stack with a singly linked list. Later on, we will look at the source code, which is actually written using a doubly linked list. Okay, to begin with, we need somewhere to start to be in our linked list. So we're going to point the head to a null node. This means that the stack is initially empty. Then the trick to creating a stack using a singly linked list is to insert the new elements before the head and not at the tail of the list. This way, we have pointers pointing in the correct direction when we need to pop elements off of the stack. As we will soon see, the next element, however, we need to push onto the stack is a 2, so let's do that. So we create a new node, adjust the head pointer to be the newest node, and then hook on the node's next pointer to where the head was before. And we use the same idea for 5 and also 13. Now let's have a look at popping elements. This isn't too hard either. Just move the head pointer to the next node and deallocate the last node. So here we pop the first node off the stack and set the node's reference to be null, so that it will be picked up by the garbage collector if you're coding in Java, and it will since there are no other references pointing to it. If you're in another programming language that requires you to explicitly deallocate free memory yourself, like C or C++, now is the time to do that, or you will get memory leaks. Getting a memory leak in a data structure is one of the worst kinds of memory leaks, especially if it's a custom data structure that you intend on reusing. So keep watching out for that, not only in this video, but in all the data structures that we will be covering. If you see in an implementation that I'm not correctly cleaning up my memory, please point it out to me, or send a pull request to the GitHub repository so we can patch that. Okay, so we keep proceeding by removing the head and advancing the head pointer down to the next node. Pop again, and pop again. There we go, we've stopped popping, we've reached last node, and the stack is now empty. All right, time to look at some source code. I implemented a stack using a doubly linked list that we can look at in some detail if you're interested in the source code for the stack. In the next
Okay, that's about stack implementation. It's quite easy, very straightforward. Okay, you've seen it in the previous video and this as well, right? Okay, let's see what I have. This is the what we have in your slides. These are illustration on what kind of functions represents a pop. Okay, when you actually see this in your icon in your software, so you see all these icons, right? That undo button is basically to remove everything that you have. For example, if you have done something in operation of typing in your documents or whatever operations you have done, you are able to pop it out, means clear it out of the way, and then maintain what you have done before. So that is basically an operation of example popping in stack. Okay, this is our application of stack. Okay, and this one, the word which you type on your document, for example, structure. First in is a first in, last out structure, meaning how you actually delete your words. Okay, so when you type structure, you can delete first in, last out, means your deletion will be starting from E first. Okay, you get what I mean? Did you get what I mean? You ever encounter this one when you type something on your document? Uh, by default, your cursor will go at the end, which is E. So when you want to delete, it works always on the place where your cursor is, which is at the word. So that is last in, because the word is the last alphabet that you have typed. So that will first come out first being deleted. Got it? Got it? Yeah. So this is an application of stack, yeah. Okay, so and this one is another application. First in, the abstraction which you put in, and then that particular abstraction versus information hiding versus encapsulation. So all those details you type, it will be pushed in into the boxes, and then after that, the last thing, the item that you get, will be the one that is appearing topmost. So that's stacking application as well. So basically, stack refers to any application that requires last in first out processing. Okay, checking for palindromes, example noon and kayak, reversing a string, etc. So um, that requires a LIFO. Then remember, always I said when you type KA, for example, KYAK, it will always read from the back first when you're trying to manipulate the word. Okay, so program stack to keep track of method calls. If you're referring to the what you call the program that you write. Okay, so to keep track of method calls. What are the method that you call in your program? Okay, so these are again the retrieve from your Java utility stack class. Okay, and it's called Java utility vector under stack. Yeah, so this particular plus stack is referring to create an empty stack. Plus empty boolean, basically whenever you say boolean, that means it always refers to return validation. It's a sort of validation. Yeah, so returns true if this stack is empty. That's why you have boolean. Plus peak element returns the top element in this stack. Pop, you have to return or remove the top element of this stack. Push is adding a new element to the top of the stack, and search is return the position of the specified element in the stack. So okay, that is stack class utility. Okay, this one is same concept with how the video operates a while ago, which you saw. All right, please go through the notes on how you reverse a string. Okay, this is how you want to, when you write um, stack, and then you want to reverse the word at the end, which is S, which is K, and reverse it back. Okay, you reversing a stack operation. We will, where are we now? We are already going to end soon. So let me see how far we still at the lecture. Wait. Okay. Okay, there is a reversing a string code, the sample source code, I mean. Reversing a string, chapter 1, example string toolkit, how to reverse. This is basically just to explain how you reverse the string, okay, by using that. These are the function source code that you can see. I believe that this one has been actually illustrated in the videos earlier, videos which I showed to you. This is how they reverse and how they do the matching of brackets here. Yeah. Mm. The one which is done in the illustration a while ago. Okay, so let's see what else we have. Okay, so this is the check for balance. I think this one has been illustrated in the video a while ago, right? So you go through this. Yeah, this is how it works. When I say how you did the checking, how you did the which one particular operation needs to pop, that. So you can go through all this illustration. So I will stop here exactly at stack. Let me see whether we still have something else here. Um, yeah, so I'm gonna stop doing the reading or explanation on the um, this illustration because that has been already covered, I believe, in the video. Yeah, and the last one would be this is the exercise um, of stacking. Stack. Transform each of the following infix expression to its postfix and prefix form. So you can try and do it maybe today, and we can discuss about this next week class. Yeah. Okay. So we discussed. We're gonna stop over here. There are a lot of other things. Yeah. Stack. Please, I want you to read through the stack section because next week we're going to continue on queues. Yeah. Yeah. So we'll stop right here. We'll stop right here until stack. Go read through the stacks operation. Okay, and I think I'm going to upload this video, this slides, new slides, which I have already appended some information for you to easy understand. Okay, I think it's a good videos to show. So far, can I know how are you? Like how do you um, can you understand the so far? How can you understand the whole lecture so far? Is it okay, class? Okay, 90% good. So basically, what you can do to increase your understanding, maybe you can, I will upload this and you can rewatch and read, go through each of the, what you call that thing, illustration. Okay, you go through the illustration and then we can proceed the next week with the recap of what we have learned again, and then you can post questions what you need me to elaborate or explain, or you can, if you have any idea that you need to add on so that everybody can get a benefit of understanding it more. Should you have any more ideas that you can, then we can have a sharing moment as well. I hope by then this problem can be solved by my problem. I can't hear you. This is very strange. I can hear my student yesterday, but maybe I don't know. It gets a bit heavy with something which I have installed. So anyway, you please have a look at the rest of the other slides. We will continue from that illustration onwards. Okay. And also please do attempt that activity. Which activity I'm referring to is this one. This one. Yeah. So you read on this one is quite interesting. Infix, prefix, and postfix expression. So, okay, that is quite interesting. So how you can actually do, yeah. Okay, any other questions? We will stop here at this point. We will continue next week for the rest of the other points. Are we okay? Good. All right, so with that, I thank you for your attendance and cooperation. Maybe later I'll see if I can post that practical notes, or maybe I can share it in the class later on. But we want to try whether or not you can execute the programs which I am sharing with you later on your practical class. So until then, I see you in the next session. Okay, thank you. So you may log out now. Thank you.